A machine learning engineer has developed a model on Amazon SageMaker AI and observed signs of overfitting, as well as the presence of extraneous features within the input data. The engineer must implement a strategy to mitigate overfitting and minimize the influence of the unnecessary features. Which approach is most appropriate to achieve these goals?
The options are as follows. Option A, raise the total number of training iterations and perform retraining. Option B, incorporate L1 regularization into the training process and perform retraining. Option C, reduce the total number of training iterations and perform retraining. Option D, utilize SageMaker Debugger to inject L1 regularization into the model while it is executing.
In this scenario, we're looking at common challenges in machine learning model development. Overfitting occurs when a model performs well on training data, but fails to generalize to new, unseen data. Meanwhile, extraneous or noisy features in the input data can often confuse the model, leading it to find patterns that do not actually exist in the population. The goal is to identify a technique that addresses both model complexity and feature relevance.
In my view, the correct answer is option B. Incorporating L1 regularization, also known as lasso regularization, into the training process is the most effective approach here. This method introduces a penalty term equal to the absolute value of the model coefficients. By doing so, the process forces some feature coefficients to become exactly zero. This effectively performs feature selection, removing the influence of irrelevant or noisy data. By pruning these unnecessary features, the model becomes simpler and less prone to overfitting. As for the other options, increasing training iterations, as suggested in option A, typically makes overfitting worse rather than better. Option C, reducing iterations, is a form of early stopping that might help with overfitting, but fails to specifically filter out the unnecessary features we are dealing with. Finally, option D is incorrect because SageMaker Debugger is designed for monitoring and profiling model performance. It is not a tool used to inject regularization directly into the model architecture during training. Keeping these distinctions in mind will help you identify the correct strategy for feature selection and regularization in your own machine learning workflows.